Hi, and welcome to this week's Love My Tool blog. Have you ever gathered a network trace with hundreds of megabytes of data and then wondered how you're going to find where a problem occurred somewhere within that trace? Well, one of the things that can help is using markers, and it's a very simple technique and it's a really big help with analysis. So the purpose of markers is to help us quickly find the area of a problem if we have a trace that's been running for a long period of time and we've got a very large trace file or lots of trace files to look at. So here's the configuration I'm going to use. I have a PC talking across my household Wi-Fi network to a small server that's running an application on Apache web server with a small database behind it. So I'm capturing a trace file on the server using TCP dump. And what I'm going to do is I'm going to wait for a problem to occur with the application, and then I'm going to send a ping packet so that it can be seen within the trace data. But what I'm also doing is I'm conscious of the fact that in many enterprise networks we also have management systems that are continuously sending pings to servers. So what we're going to do is we're going to use a ping with a distinctive length so that we can find it quite simply. Let's have a look at the application. So the application is quite simple. We have a list of work items, tickets, and we simply click on one and detail of the ticket is shown. And then we can click on another ticket and we can look at the detail. And as you can see, it's quite responsive, but every so often it gives a poor response time. So let's see if we can recreate that. Let's try another one. Okay, 1, 2, 3, 4, 5 or so seconds. Let's quickly send a ping marker. So here you see that I have a ping marker of a length 101 bytes. So I'm going to send a single ping because by default Windows sends 4. I'm going to send it with 101 bytes to the server. So we should be able to find that in the trace. Now just to make things a bit more interesting, let's do a few more of these so that we can we have some other traffic before and after. And I'm just going to inject some more traffic in another system from another browser that I have running on another laptop. Okay, so we should have enough there. So I'm going to stop the trace and then I'll download it and we'll take a look at what's in the trace. Here we see the contents of the trace file. Even before I start to filter it and do any work on it, you can see that we have a ping request here. But if we look at the length, we can see that it's only a 32 byte ping. And this was because I set up another machine to mimic a management station by regularly pinging the web server. Let's see if we can actually find the marker that I'm really interested in. So if I just put in a filter expression where I'm looking for an ICMP packet with a data length that's equal to 101 bytes, there we go. I go straight to the point where the problem occurred, 101 bytes. And the other thing I need to know is the IP address of the machine that actually had the problem. So let's get that address. And we can see that the address of the machine I was using was 192.168.1.73. So if I put in 192, IP address 192.168.1.73. Now I can see my ping, and just before my ping I can should be able to find my last request from that PC, which is, I guess, is this one here. And as we can clearly see, if I just take out some of the TCP control data, you can see that I've got a GET request here, and then I've got a sequence of packets, which is the data coming back from the GET request, and you can clearly see that I've got a 6-second delay there. So let's add in the marker so that we can compare exactly where we are against the marker. So it's an ICMP packet which has the data length equal to 101 bytes, and there we have it. So there you can see my marker. Immediately before that you can see the last transaction for that user, and you can clearly see that there's a 6-second response time. So that's pretty easy to do, but there's something we can do that's even more clever. And if we just let's just clear that for a second. What I'm going to do is I'm going to restart the trace, and I'm going to recreate the problem, but I'm going to use a slightly different type of marker. So let me get prepared for that, and I'll show you exactly what happens. In this example I have the same configuration, but this time I'm going to use HTTP to generate a marker, and I'll show you the advantage of doing that in a second. So let's go back into the application and try a few things again. So we'll try, you can see that we have pretty rapid response times here. One, 2, 3, 4, 5. Again, a bit more than 5 seconds, somewhere around that. So that's the slow response time. Now this time, rather than send a ping marker, what I'm going to do is I'm going to just specify a URL with something distinctive. So you can see that I've just typed in mark101.html. There is no page mark101.html on this website, but that doesn't matter. So I enter that, and of course I get an error, page not found, 404. Now let's do a few more things on here so that we make sure that we've make things a bit more interesting for ourselves. So I've sent the marker. Oops. Okay, so again I'm going to stop the trace, download it from my web server, and we'll have a look at what we have. Here's the trace file, so let's do a find within the trace file, and we need to find mark 101, and it takes us straight there. So we can see our marker, and we can see that sure enough the website gave 404 not found as the error. Again, we can use the same techniques to filter the trace, and this time we're just going to do it this way because we've got the 404 error already, and so immediately before that we can see the actual slow transaction. So we see again that we have a transaction, a GET request here, and 6 seconds later we get the response. Across my Wi-Fi we also seem to have had a retransmission, which is just another little gem for us to look at. Anyway, we can see that there, we can see the 6 seconds response time, but what's even better is because we've used an HTML or a web-based marker, if we pull up the actual web logs and we do a find in the web logs for Mark 101, we go straight there, and we can also see at this point here in our weblog, this was the slow transaction. And what's more, because I've enabled response time monitoring in the weblog configuration, you can see that the weblog is clearly showing that we have a 6.149628 response time from the web server. So I hope that helps. Have fun with that, and I'll see you next week.